Hello physical science student, welcome to video 1.1, the very beginning of videos. And you're going to be watching a lot of videos in the course of physical science, but this is a momentous one, it's the first. And so it's starting our topic, which is atomic structure, which is loosely based on chapter 1 in your chemistry textbook. And we're going to go through a few topics as we work our way through. And so just make sure you watch these videos and you're taking your video notes as we go. And if you need to, pause, read the stuff on the screen, or go back and listen again to what I'm saying in case you don't follow it. That's the advantage of the videos. Now, first off, in atomic theory, we've got to think about the kinetic theory of matter. Now, that sounds pretty neat, doesn't it? Well, what is the kinetic theory of matter? Well, it's a theory that explains matter. Matter being the stuff that we're made up of. Everything you can see, touch, breathe, all the stuff in the universe. And people have been wondering about this stuff ever since we first started wondering about wonders. And you can go back to the Romans and the Greeks, even the Greeks way back. I think it was Aristotle. He, or one of those Greeks, they had the idea that to explain matter, because humans think, they go, what makes that tree, or what makes that rock? And they have to have some explanation. And even though we have a pretty good understanding, there's still lots of questions to be asked, of course, in science. But if you go back to the Greek time, the understanding was much more simplistic, and so, but they still had some good ideas. For example, they thought, the Greeks, that everything was made up of three things to start with: earth, fire and water. And you think that's a bit weird, because we now know that all those things are made up of different things. But if you look at it, so they looked at something like a tree, and they said, well, a tree must be made of bits of all of that. Earth, because it's got roots in the ground and it needs to feed off the earth. Water, because you've got to water it, or it dies. And fire, because when you burn it, it makes fire. So it must be made up of those three things somehow or other. And they left it at that, but with lots of questions still unanswered. But through time, we've evolved a better and better understanding of what makes up matter, and this is where we're going to go from the current understanding of the kinetic theory of matter. So some key points. First off, all matter in the universe is made up of tiny invisible moving particles. Now, they're so tiny we can't see them, therefore we call them invisible. They still exist, but to our eye we can't see them. But we can see when there's lots of them, because we can see matter. How do we know that they're moving? Well, that comes on later on. But that also explains some things. Particles of different substances have different sizes. Okay, and we've done some experiments that can prove that, and you can do a simple one at home. You can blow up a balloon and then tie it off and let it sit there, and it will shrink as it deflates. How is it deflating? Because some of the molecules are actually going through the rubber and escaping back out to the air. That's what's happening, and that's the explanation of what's happening. Lighter particles move faster than heavy ones in a particular or at a particular temperature. We can do that with the example, the way if we had a big room and someone sprayed some deodorant in one corner of the room, you would smell that deodorant eventually on the other side of the room. It would sweep across the room gradually, and so it's moving relatively fast for a tiny particle that then goes up your nose. Whereas if someone spilt some water, for example, in the corner of the room, you wouldn't suddenly feel wet on the other side of the room, simply because the particles are moving. A little bit different, but sort of what we're trying to say. As temperature rises, the particles move faster. Now I'll show you an animation that keys that in. In a solid, the particles are very close together and vibrate in fixed positions. So the kinetic theory of matter explains why we have different states for things. So when we have a solid, the particles that make up matter are locked in place. When we have a liquid, the particles can move a little bit more. they're not locked into the same place, they move around. They have more energy because they're moving around more, and that's why it's a liquid. But then when you get to a gas, so we're looking at three different states here: solid, liquid and gas. In the gas, the particles are far apart and moving rapidly, and I'm going to show you a demonstration about that. And so this is the nuts and bolts of the kinetic theory of matter. It explains why we have solids, liquids and gases predominantly. And this is a little diagram that you can look at. So here you have the invisible particles. Okay, you and I might call them atoms. Strictly speaking, they're not all atoms. They could be molecules, they could be ions, they could be a variety of things, but they can only be certain things because we know that. But in the solid, they just sit around and vibrate a little bit, but they're locked in position. It's sort of like you sitting in the classroom. You're sitting there, but you can fidget and you can move a little bit, but you're pretty much locked in position. For a liquid, as I was saying, for a liquid, it's slightly different. The particles are sort of in positions, but they can roam a little bit. It's like if I put you into groups and made you work in groups, you'd move around the bench in the experiment, but you'd still be pretty much stuck in the same place. Whereas for a gas, it's like I fed you all with red cordial and it was a really hot day, and I said you didn't have to sit in your seat anymore, and people would just be running around all over the place. And that's the different states, so from solid, liquid to gas. Now, when we go from one state to another, we have a few terms that relate to them, or that process, and most of which you would know. For example, if you go from solid to liquid, so from ice to water, that's melting. To go the other way is freezing. Liquid to gas is evaporation. To go from gas to liquid is condensation. Okay, and there's one other term which you may not have heard of, and that's one called sublimation, and that's where you go directly from a solid to a gas. And there's a couple of examples of that. The most common one would be dry ice. You have a chunk of dry ice. Dry ice is made up of carbon dioxide, and it doesn't get wet when it melts. It goes from the solid to the gas without a liquid stage, and so that's called sublimation. Now, there are effectively four states of matter, even though most people only think there's three. In recent years, we've added on what's called plasma. And plasma is what you see on the sun, but it's also what you see in welding torches, and what else do we see? Fluorescent light bulbs have a plasma in them. Okay, now matter can change from one state to the other, and that can sometimes be related to pressure, but it's also related to temperature. Now, we don't deal too much in physical science with variation in pressure, but just be aware that that is just as valid a reason. It's why if you go mountaineering, it's hard to boil water on the top of a mountain because the pressure is different. It doesn't relate to it being real cold, it's the pressure that makes a difference. But we're predominantly dealing with temperature in physical science. And so the melting point is the temperature when a solid turns to a liquid. So that's a phrase that we'll use a little bit. We sometimes summarize it just as MP. And the reverse is the freezing point. We then have the boiling point where a liquid turns to a gas, and the condensation point. So they're just a few terms that we do use every now and again. And this little diagram shows it all. For the most common three states, and then remembering there's plasma outside. And again, there's our plasma. So what is plasma? Plasma is when electrons detach themselves off the atom, and so you have things called ions, which don't have the full quota of electrons, plus electrons moving around independently. So it's got to be very hot for that to happen. Let's go to the animation. Now, what do I need here? I have to press this button, and I need to go here. There we go. Okay, so this little animation, and I'll try and put this on the physical science OneNote, but sometimes these don't work in the shared environment. So here's our solid. You can see the particles are moving around a little bit. If we go to a liquid, the particles are still clumping together, sort of like you have droplets on a leaf. They like to clump together. They have what's called surface tension. They're attracted to each other, but they're moving around and they're not locked into positions. And if we go to gas, all the particles, whatever they may be, are moving around a little bit. Now, you probably can't see what I'm touching. There we go. Let's move that across. Oh, no, damn thing. It's got a mind of its own. Here we go. Get off there. Oh, it did it again. Anyway, so let's go back to the solid. Let's imagine, I'm doing this behind me. Let's just make it water. There's water. So we've got H2O, so 2 hydrogens and an oxygen, and they're in ice. So they're locked into a sort of crystal structure. If we add heat, there we go. We're heating it up, and we've got our temperature. It's in kelvins, so we could actually put it to Celsius. So 40 degrees, let's heat it up, and it's gone to liquid because it's water and it's starting to evaporate, and now we're getting water vapor or steam. Okay, and all the particles have so much energy they can't keep together, and if we cool it down, they'll start losing their energy, and the energy is predominantly as what's called kinetic energy, the energy of movement, and you can see they're not moving nearly as much. There we go, and we've just frozen it at minus whatever. If we looked at another molecule, oxygen, there it is solid oxygen, very, very cold, minus 242 degrees. We got to heat it up, and it will go, or we just change it into a liquid. It goes into a liquid at 204 degrees, minus 204 degrees, and a gas, which is minus 79. So anything above minus 79, oxygen is going to be a gas, which is a good thing, otherwise we couldn't breathe. Right, let's go back to our PowerPoint. I think this is it. No, I think, there it is. Okay, let's just check I haven't done anything. Right, so let's have a look at some questions and how we can use that understanding. Here we have benzoic acid, and we want to identify the state of a substance given a few of its properties. Now, it's used as a food preservative. That's a bit of noise just to confuse you. Has a boiling point. Remember what the boiling point is? That's going from liquid to gas of 249 degrees C, and a melting point of 122 degrees C. What state is it at 25 degrees? Okay, just normal pressure, so that's room temperature and pressure. 25 degrees, so that's below the melting point, and so below the melting point it's going to be a solid. Yep. Now at 155, that's going between the melting point and the boiling point, so that's the transition from liquid to solid. This is the transition from liquid to gas. This is the transition from solid to liquid. All gets a bit confusing. So if at 155 should be a liquid. Let's have a look at it. Yes, got it right. And it's a liquid. Got it right. So there's a couple of questions there for you to do out of your textbook. They'll be highlighted on your OneNote, and so you'll need to be able to do those. Now the answers should quickly appear because I sometimes use this in class. And in the next video we're going to look at the atom. So, cheerio!